Hi friends, today I'm going to upload two videos in continuation to the previous theorems on circles. And this is the first video in which there will be some short theorems but important ones. And the proof of few I will discuss, whereas others I won't. And here is the explanation for the first one. Let us consider we have a circle with center O, in which AB and CD are two equal chords. And if AB and CD, if these two chords are equal, then these two chords have to be equidistant from the center. Means if OM and ON are perpendiculars from the center to these chords, then these perpendiculars have to be equal in length. The theorem states that equal chords are equidistant from center. And if we need to prove it, then it is very simple. The proof is very simple. We just have to prove that this triangle, that is triangle OMA, is congruent to triangle ONC, and by CPCT we can prove that the distance OM is equals to ON. The converse of previous theorem is very much true. Let's see how. Again, we have a circle with center O in which AB and CD are two chords. Now I do not know whether these chords are equal or not, but it's given that these two chords are equidistant from the center, that is OM and ON drawn perpendiculars to the chords, these perpendiculars are equal. In that case, the chords AB and CD have to be equal. Now how can we prove it? We can easily prove by joining OA and OC and proving that triangle OMA is congruent to triangle ONC, and from CPCT we can prove that AM is equals to CN, and if AM and CN are equal, their twice will also be equal, means AB and CD will be equal. Let us see how can we draw a circle which passes through three non-collinear points. Let us consider we have 3 points A, B and C. What we have to do is we have to draw a circle which passes through all 3 points, that is A, B and C. Step number 1 is join points AB and then draw a perpendicular bisector to AB. Now each point which lies on this perpendicular bisector is equidistant from points A and B. Next step is join BC. Again draw a perpendicular bisector to BC. Now every point on the perpendicular bisector of BC will be equidistant from points B and C as well. Now there exists a common point on the perpendicular bisectors of line segments AB and BC, and that point is O, which means O is equidistant from all 3 points A, B and C as well. And the definition of circle says that it's a locus of all points equidistant from a given point, and that given point is the center of a circle. So it means O is a point which is equidistant from A, B and C, means O will be the center of our required circle. Now taking OA as a radius and O as a center, we can plot a circle, and this is our required circle. This circle will pass through all 3 non-collinear points, and remember there is one and only one circle which can pass through 3 given non-collinear points, because the perpendicular bisector of AB and BC will intersect only at one point, means there will be only one point which will be equidistant from the 3 non-collinear points. Let's start with the next theorem. We have a circle with center O, in which AB and CD are 2 equal chords, and if these 2 chords are equal in length, in that case the corresponding arcs, arc AB and arc CD, will be congruent. So the statement of the theorem is, if two chords of a circle are equal, then their corresponding arcs are congruent. The converse of this theorem is also true. Let us consider we have a circle with center O, in which AB and CD are two arcs. If these two arcs are congruent, then the corresponding chords AB and CD will have to be equal, and the statement of the theorem is, if two arcs of a circle are congruent, then their corresponding chords are equal. Thank you so much for watching the video, and next video I'll be discussing another important theorem along with the proof. Hit like button and subscribe to watch more videos. Till then, thank you and have a nice day.